Alrighty guys, inverse functions. We've seen all of this before, but we're going to re-talk about it. Inverse functions, I'm sorry, right there. Anybody else need one? Pretty good? Okay, so there's like lots of writing, and you can read that. But I'm trying to pick up for time that we lost. Inverse functions, when you graph them, the inverse is always flipped over the invisible line of y equals x. Always. Now, just because something is originally a function doesn't mean its inverse is a function. Its inverse is a function if the function is a one-to-one function. Meaning there's only like one x and one y combination, and those numbers aren't used more than once. Like, and a fast way to figure that out is called a horizontal line test. I know you guys are familiar with the vertical line test, determining if the function or if the equation is a function. The horizontal line test will tell you about the inverse. If you test it horizontally, this touches in two places, so the inverse is not going to be a function. And you can prove it graphically. When I flip it over, that equation of y equals x right there, it's going to look like this. Does that pink stuff pass the vertical line test? No. So it's not a one-to-one function, even though this is an inverse. You can kind of see an example sort of right here. Also, I don't like that got... Yeah, we'll flip it over and we'll do it on the other side. Go ahead and flip your paper over. Let's jump into the examples because it's not going to be that hard. At the top, how to find an inverse. This is super simple. Step 1, you replace f of x, that's the name of the function, with the letter y. Step 2, this is the biggie. Swap the x and the y, they trade places. Step 3, solve for y. Step 4, replace the letter y with this notation. This notation, that is not an exponent. It means inverse of x. Alrighty? So number 1, find the equation for the inverse of f, that's what that says, if f at x equals this mess. So step 1, replace f of x with a y. Step 2, swap the x and the y's, they trade places. So everywhere I see a y, I put an x. Everywhere I see an x, I put a y. Step 3, solve for y, get y by itself. Most of us are not like super fans of fractions, so let's multiply both sides by y plus 1. I need y by itself. What do I do? When you see that, what do you kind of want to do? You want to distribute, so let's go ahead and do it and see if that doesn't get us somewhere here. Now we know for sure to get y by itself, they all need to be on the same side. So let's subtract xy from both sides to get the y's on the same side of the equation. I've got a couple of y's now. How can I get that to just a single y? Factor, factor, factor. So x equals, pull out y, and I have 1 minus x. And you could probably do the last step on your own. Step 4, replace the letter y with the notation for inverse. And I'm also going to flop left and right because textbooks like that, math teachers like that, students like that. So there's our inverse right there. Questions on what you're supposed to do on those? Questions on that particular problem? Fantastic. You guys do the next example all by yourself. How'd everybody do? Once you replace it with a y, square both sides to get rid of the, or I'm sorry, you swap the x and the y first. Square both sides to get rid of that radical. Subtract 3 from both sides, replace the y with the function notation for inverse. Questions? Awesome. Next thing, and then we're done. Verifying or proving that two functions are inverses. It's called the inverse composition rule. There's lots and lots of words here. Let me break this down for you. It means, here's the translation of all of this math stuff. If f of g of x and g of f of x both equal x, then they are inverses. Now let me tell you, worksheets, workbooks, textbooks, teachers are tricky. Just because f of g of x and g of f of x both equal the same thing doesn't mean they're inverses. They both have to equal x, and not just any x, it has to be positive x. Alrighty, so watch that. Let's look at our example. They give us the function for f of x and g of x, and they want us to prove that they are inverse functions. So let's see here. I have to find first f of g of x. That is not fog, that's f of g of x. That means, and because this is my notes, I'm going to draw an extra little thing in here. I'm going to take g of x, plug it in to the function f. That's what's going to happen. The function for f of x says x cubed plus 1. Instead of x cubed, I'm going to put this thing cubed. So the cube root of x minus 1 becomes my x. So x cubed plus 1. Does everybody see what happened? I took g of x and plugged it into f of x. And now we work it out. What happens when you cube the cube root of something? Root pops off, right? So we have x minus 1 plus 1, which is x. Now if I didn't get an x, let's say I got negative 2, or let's say I got x squared.
Is Heather here?
She is, yes. Did you have a split to give her? Did you give your password? Did you check back in? Or were you just on the phone? Okay. They're just going to think I screwed up. It's fine. Let's say you got like negative 2 or x squared. Could you stop or would you have to keep going? You'd have to stop because it means that they're not inverses. Now, because of the way that this is written, you know that they are inverses. It says to prove that they are. You might have a question that says, are they inverses? So if that didn't have an x, you could stop and say, no, they're not inverses of each other. But we got to keep going. We got x. Let's keep working. Now we're going to find, let me get a different pen, g of f of x. It's not goff. G of f of x. That's where you take f of x and you put it in for that x. So now I have the cube root of, not x minus 1, but x cubed plus 1 minus 1. We simplify it so that we have the cube root of x cubed, because negative 1 and positive 1 cancel each other out. The cube root of x cubed is x. I got x on both, so we're good. So for the ones where you're proving something algebraically, the steps are the answer. So don't short me on steps, because that means you didn't finish the answer. Questions? Last thing, and it should have been on this notes here. I'm going to fix this for next year. Do me a favor, put a little grid in the corner where you've got some space. Put a dot at negative 1, 2, 0, 1, and 2, 3. Let's pretend that's part of a function and you have to graph the inverse, and that's all you're given. We know that the inverse is going to be reflected over y equals x. And we also know something about it because earlier in our notes, I told you to swap the x and the y's. That works on a t-chart also. So if you make a little t-chart, my points are negative 1, 2, 0, 1, and 2, 3. If you switch the x's and the y's, and then graph it. So instead of negative 1, 2, I have 2, negative 1. Instead of 0, 1, I have 1, 0. And instead of 2, 3, I have 3, 2. You'll see a mirror image. And that's how you can graph an inverse. Questions? Everybody okay? So T-chart, swaps the x's and the y's, and you're good. All right, let me freeze on that.